So what's up everyone? Welcome back to the channel. So if you ever tried reading upon big data frameworks and found yourself starting at a wall of text talking. So you can see the wall of text talking about distributed, monolithic, and like this particular distributed monolithic aggregates, or it can be like serialization codex, and even you can able to close that browser. So if even if we even now even we can close that browser tab right now. And so today now today's session we are converting every single major question I'm going to present over here. So by so we are going to convert these concepts into plain and simple English. And here I'm going to use the systems we daily use, like Slack, Netflix, and GitHub. So based on Slack, Netflix, and GitHub, I'm going to present to the particular. I'm going to present the concepts what we are going to learn today. In the previous class, we have seen, uh, so we have started with the absolute basics. So actually, what on earth is cloud computing in relation to big data? And where we have think of it like renting computer power on Amazon Web Services, it's nothing but shortly called as AWS. And instead of tiny tech startups spending millions and start spending millions to buy a physical room full of heavy server hardware to analyze logs, like instead of spending millions of rupees for buying physical room with a full of heavy server hardware to analyze logs, they rent they rent a chunk of cloud for a few hours for the requirement, and they're going to run their code. And after running the code, if they are not want to use it, if they're not if not utilizing the particular servers, they can shut down it. They can shut down them when their usage was completed. And we have seen how we can define big data. So with an example of Uber, so where there is a where we deal with the volume for millions of rides and velocity regarding GPS updates, streaming every single second while using the particular ride, and variety and nothing but profile pictures. Variety is nothing but profile pictures in images, and text reviews in text data, and payment logs in unstructured data. So we have seen about variety, and even we have discussed about coming to data. So it is completely available in three flavors: structured, like Excel sheet of transaction histories, and semi-structured, like a flexible JSON file, and unstructured data like a customer service, call audio recordings in form of a like audio files. So we have covered till here. So now today we are going to start the segment 2, that is the Hadoop factory and HDFS. HDFS stands for Hadoop Distributed File Systems. So without any late, so let's talk about Hadoop. And coming to Hadoop is essentially an open source operating system for a cluster of linked computers. So we're not going to have a single computer over here. We have cluster of linked computers, and we are going to have a file system. It runs on it is going to run on this particular linked computer. So for the reason we are going to call as Hadoop distributed file systems. So when you think of in a simple manner, when you think of Hadoop distributed file systems, it will be like a GitHub repository, storage setup. It is like a GitHub repository, storage setup. If you try to upload a massive 1 GB, if you try to upload a massive 1 GB, system log file. This particular Hadoop distributed file system won't try to, so it won't try to show it on the one hardware drive. It will not show it on the one hardware drive. So it try to chops. It will try, this particular Hadoop file system will chops it up to 128 MB chunks. So 1 GB will be chopped into 128 MB chunks. And of, to managing this particular data in these Hadoop distributed file systems, there will be a master server called a name node. This particular name node acts like the Git. So we have GitHub where the files are going to store. For controlling this particular GitHub repository, we use Git in our particular laptop. So similar as Git for GitHub, for this Hadoop distributed file system, we have name node like the same. So this particular name node will exactly know where every single file chunks are living. It will know where single file chunk is going to be present. And under this particular name node, we have worker nodes. So under this particular main server name node, we have worker nodes. So we call this worker nodes as data nodes. Okay, these data nodes are the actual. This is actual attribute where the actual piece of data is going to be stored. Okay, so finally, to ensure this particular fault tolerance and file distribution system of these pieces, and try to if you want to replicate them across three different physical servers. So there will be so now we are in. Now we are in segment 2, that is the Hadoop factory and HDFS. So we have Hadoop file system. So the in Hadoop file system, there will be name node. There will be name node. This is nothing but the master server. So under this name node, related to data, we have several chunks of data. We have several chunks of data. So each and every chunk is going to be held by data nodes. Data node 1, data node 2, data node 3, data node 4. This will be master. These are the workers. These are the workers. Nodes for a name node, that those are called as data nodes. And if you want to ensure like fault tolerance, if you want to ensure fault tolerance, this this HDFS takes those pieces. So this particular HDFS will takes will take this particular will take those pieces and replicate them to three different three different physical machines. So there will be three different physical machines. There will be three different physical machines. There will be server A and server B and server C. In server A, in server A, randomly catches fire in the data center. If in case there will be fire accident for server A, the data center. So the platform will try to seamlessly this particular platform seamlessly switches to copy B. So instead of using the file, if there is a file, this particular server A will not work. It will then this particular services will be related to server B. So without your live application dashboard, so if you're having your live dashboard, okay. So without dropping a single frame, it will try to redirect it to server B. And if the server B like get crashed in any reason, it will redirect to server C in this manner. So how many safe servers you want to have for your particular application, those many servers you can able to create. So this is about the Hadoop factory and Hadoop file systems. And now we'll deal with the now in this particular segment we'll deal with a particular question. Fourth one is on convergence of technological trends leading leading to big data. So coming to definition. So the big data emerged because the big data was emerged because several trends. So we so nowadays we have several trends are going to exploded. Due to the exploded several times, this big data was emerged. So like the one of the trend is nothing but the boom of web traffic. So like continuous 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 triggering of data to a particular server. So it will give rise to the boom of web traffic. And there's a rise of smartphones. So before this, this particular applications are only used in computers or laptops, but now, so like even even the particular applications like are enabled to run on smartphones. So this due to the rise of smartphones also. And even social media. So back 15 years, we could not expect social media, so much social media, back 10 years, we will not expect much social media. But now, without social media, no one wake ups and no one gets sleep. So from wake up to sleep, so everyone is everything is revolving around social media. And in back days, there is a high cost for IoT sensors, but with respect to the increase in the production and usage, the IoT sensors got cheap. And this got cheap, so we can have constantly broadcasting data. So during it, the particular IoT sensor getting cheap, we constantly having broadcasting data. And even we have affordable infrastructure. So we having affordable cloud infrastructure to store it all. So if you want to store any particular data, so now it was affordable. Now it was very affordable to everyone. This was a simple explanation for convergence of technological trends leading to big data. Now let us break down with an IT example, with a real-time IT example. So nowadays, so not in everyone's home. So some are other locations, some other place, or in any in your neighborhood or anyone's neighborhood, we would expect. So when you look news also, you can see such type of articles related to smart home ecosystems. I heard about smart home ecosystems in newspaper or in news or or else in your particular neighborhood. This particular smart home ecosystem, like for example, so in UK, in USA, we have Apple Home Kit. So people who are having Apple phone, like laptop, so Apple ecosystem in their home, they will have this particular Apple Home Kit, depending on with respect to their affordability. So this particular why we are having smart home, why the particular current situation is supporting smart home ecosystem, because of the cheap microchips in the light bulbs also. We can see this cheap microchips are present in light bulbs which are using in our homes. This is nothing but this works on like IoT. So this we are integrating our light bulbs with IoT to follow our commands. And we have mobile applications. So if we are using smart light bulbs, so we can able to connect with our mobile application. So for that particular smart bulbs, the manufacturer will try to create a smart mobile applications on iPhone, for example, iPhone. Okay, so we have mobile application on iPhone for our smart light bulbs, which is enabled with IoT. and for with the constant cloud syncing. So with we are connecting with this with Wi-Fi or a Bluetooth. So constantly it is going to have a cloud syncing. So it is going these both are going to have these both are going to be in cloud sync with any particular technology. So we have good infrastructure also. Even we are staying at out of home also, we can able to make our particular light bulbs to glow on our command. This is one of the example. Even okay, fine. This is one of the example. This is one of the example. This is the one of the example, and second example is nothing but what are the files? What are the files capturing or downloading into your devices will be cloud sync constantly. So when you are having capturing any particular photos, when you're downloading any particular files, it is going to have constantly cloud sync. And next, so we have million users. We have millions of users checking apps. Okay. With respect to that, it gives you flood of telemetry. Telemetry is one of the thing required for GPS streaming. What were mentioned above? What were mentioned above? So these are that they did not exist back 20 years. What I'm mentioning over here, it does not exist back 20 years in our world. Right now, it has given rise due to the convergence of technology trends leading to the big data. With an example. So we will move to next topic. Next topic is open source technologies. Open source technologies for big data. So let us dissect this particular explanation. Okay, like even Hadoop is a particular open source software toolkit. So we are having Hadoop for big data, for big data storage and management, data management. We use Hadoop. This Hadoop is a open source software toolkit. This particular Hadoop lets you to link dozens of cheap computers. So we having we have like a low con like we have we have a sufficient configured computers, right? So what are the computers we are having with us? This particular Hadoop will link with those available computers together. So when you link with those but available computers together, so they're going to act as a giant storage. So it makes this particular Hadoop makes our available computers to work as a giant storage, and it is going to use it is going to use this processing engines. It is going to use the processing engines, nothing but the processors available in those computers. And this particular Hadoop has three pillars. This Hadoop is having three pillars. This Hadoop HDFS, that is Hadoop distributed file system. This Hadoop file system is one of the pillar. And next will be MapReduce. This will be the calculation engine. So what was the particular storage utilized? What was the particular processor utilized? This particular MapReduce is going to look after in the Hadoop. And next pillar will be Yarn. So coming to AN stands for 8 another resource negotiator. negotiator, where HDFS stands for Hadoop Distributed File System. The same manner, AND stands for 8 another resource negotiator. So this it is going to have, it will be the manager, it will be the manager allocating resources, allocating resources. So in the Hadoop, here's a simple explanation about open source technologies for big data. Simple introduction about Hadoop. Now let's now let's now let's break down with a IT example. So we have like think of Android OS tools versus Apple. So we have Android OS tools and Apple tools. So where both the companies, both the companies are paying millions for a closed, they are paying millions for a closed, both are for not only a single one, both are paying millions of closed, like proprietary proprietary data suit, and an enterprise IT team. So this particular closed and proprietary data suite related to data, and and they are going to like these are the investment. There's an investment and technology coming to uh, coming to resources or the labor. Okay, so coming to in any organization we have land, labor, investment, and capital. Okay, so they pay like if they are having capital. By using capital, they're looking for closed proprietary data suites and enterprise IT team. This is a labor or manpower for a company. They are making their enterprise IT team installing free stack of open source software. So even companies will look for open source software only instead of licensed one. They will try to make their work done with in done with any particular open source softwares available in the market, because they need not to pay any amount for licensing. So like they will use free stack of open source softwares like Apache Spark and, as we discussed, Hadoop Hadoop software. So why we they use Apache Spark and Hadoop to build their own custom data engine, for building their own data engine. They will install this free stack of open source softwares like Apache Spark and Hadoop. They look for closed proprietary data source, and for the same reason, they make their enterprise IT teams to install free stack of open source softwares like Apache Spark and Hadoop to build their own custom data engine for processing and synthesizing their continuous data, that is big data. Now we discuss about Hadoop architecture and core storage of HDFS. And we are we have completed five different topics till late. So now let me introduce the sixth topic, that is on Hadoop framework. And its basic components. Now let us imagine an IT help desk department. Let us consider a IT help desk department. So where Hadoop where Hadoop is a department, where Hadoop is a department operating system, and the HDFS Hadoop data had a Hadoop distributed file system will be the cabinet, will be the cabinet system having a cabinet system around the room. And next we have MapReduce. We have MapReduce, right, in our architecture. Coming to MapReduce is a step by step workflow, which is a step by step workflow. So the particular technicians, of particular IT decks, the technicians available in the IT help desk used to solve tickets. And we have yarn, that is eight eight, eight another resource negotiator will be our help desk manager. This particular yarn will be work as our help desk manager for scheduling who works on what ticket. And next we will discuss about give me a moment. Let us start the topic in a while.